Hi, my name's Doug, and it's great to be able to meet with you tonight. I'm doing a electronically assisted astronomy live session here from Emerald Hills on the outskirts of Louisville, Kentucky. Pretty high light pollution situation. I don't know what the exact Bortle reading would be if you're into that sort of thing. Bortle 6, I don't know. All I know is there's quite a light dome over the city of 1.5 million people. But I thought I'd just walk through the pieces of at least what's happening with my journey of EAA, and you can compare it with yours. And if you haven't gotten started yet in astronomy, I'll try to throw in a little bit about what I'm learning along the way. And then if you are experienced, I'll look forward to learning from you. I sure have a lot to learn. This is about my sixth night out, so I'm just sharing where I am on this journey. As you can see right now, you're looking at Sky Safari. It's a planetarium program. You can see that our scope is pointed right at Polaris, the North Star. The software that I am using for connecting to the mount that controls the telescope is called Green Swamp Server. I'll just show you the little control panel for it. You can see it really does a pretty good job of showing a graphical image of your telescope on a pedestal or tripod of some type, and then a German equatorial mount here with the weights on the end balancing out the telescope. And we usually refer to this part of the rig as the optical tube assembly, the OTA. So this section is again the mount and the tripod. So just so you can kind of get your bearings, I'll go ahead and show you the targeting software that we use. Uh, it's called Astral Planner, and we've already gone through several targets tonight. We're ready for this one called M63. Going to make sure that our scope is connected to our targeting software. We're ready to slew there, but I think before I do, slew means go to, of course. Before I do, I think we'll connect you to a webcam outside the Ford Expedition truck that I'm sitting in, and I'll have to shine a flashlight out the window and make sure you're seeing that. Yeah, so you can see there's the tripod and there those weights, just like you saw the graphical image, and there's the mount, a Skywatcher EQ EQ6R Pro, and then you can see it's a RASA 8-inch scope, a Rowe Ackerman Schmidt astrograph. And on the end there, you see the black dew shield, and it's ready to slew. So we'll just uh, indicate to that Astral Planner software to slew to our next target. And if everything's good, yeah, there you can watch the scope slew around. And you know, the mount is really an important part of the scope if you want to be able to see a lot of objects on a cold night like this. I don't know, it's probably 20 degrees, feels like temperature out there right now. But the mount's really important. It allows me to sit in the back of this Ford Expedition, connected via uh, a longer active serial port connection, and the laptop tells the mount what to do. And that way I can be in here in shirt sleeve temperature. Like I say, it's probably 24 or 20 degrees out there, feels like temperature. And inside of here, inside the Expedition, it's 69 or 70. I think the next software that we'll go to would be the software we actually use to view uh, the night sky. And that's a software that's pretty common among EAA, that's electronically assisted astronomy, don't forget, EAA practitioners. It's called Sharpcat. And our camera's already connected. So the next thing we'll do is we'll do what's called a plate solve. And what we do in plate solving is we uh, allow the software to look through the camera, through the scope, to be able to see some of the stars that are there, and then it compares those stars to its own database of this part of the night sky. And what it tries to do is uh, locate the object exactly in the middle of the screen that you were wanting to see, and you can see that it did. We were just 0.01 degrees off, so it's pretty happy with that. I think we'll go ahead and put in the name here now, M63, and the next thing, let's see, check our exposure. We're using 10 seconds on our ZWO ASI 183 MC Pro camera. And with the RASA, there is no eyepiece. The camera is your viewing mechanism. Let's see, we've got a 200 uh, gain right now, which should give us plenty to see there. Let's go ahead and reset and do an auto stretch. And then let's start our live stacking frame. And let's reset this um, histogram. And let's just do enough of an auto stretch to get it started. Then let's do a reset of the color balance and just a quick estimate of what would be the color. So to get this started, we're going to grab this black level and bring it over here just on the other side of that. You can see those colors are peaking right there. Then we've got the white over here against the end. Let's bring the mids down somewhere right here. Now you can see our object here that we're starting to look at, M63. It's starting to show up quite a bit of blue, and you can see the blue is run up here. But you know, we didn't have very many frames when we did the original reset of our color matching. Now we've got 6 frames, so we've got a little better view, but it still wants to drive up that blue. You know, I think I'm just gonna figure out that maybe it doesn't know for sure what to do with this yet. Probably needs a few more frames. Another thing we can do sometimes is reset this display histogram, give it kind of a new start, and let it kind of again see more frames. Boy, the color is just not cooperating with the program very much, is it? Again, we're gonna bring this in until we can see that object. Lots of blue there. I'm just going to bring it down manually again. So this is M63, and M63 is sometimes nicknamed the Sunflower Galaxy. It it's got a unique history, and I'm trying to learn how to use um, the the audio from the planetarium software that I use. So I'm going to just test that. I don't know what it'll sound like. Here goes.
M63 is a bright northern galaxy in the constellation of Canis Venatici. This spiral galaxy, sometimes called the Sunflower, is bright enough for enjoyment in both the small and large telescopes. Locating M63 can be a bit tricky, since it is in an area with few guide stars in the sparsely populated region under the handle of the Big Dipper. To find M63, imagine a line from Alkaid, the end star of the Dipper handle, and connect this to Cor Carili, the leader of the hunting dogs. Incidentally, this star is a very fine double in small telescopes. Once these stars have been spotted, find the midpoint between the two. M63 will be nearby. In small telescopes, M63 is a dot with a haze about it. Larger telescopes show the inner and outer structures with hints of riches within.
Okay, so we're kind of closing in on this object M63. I love the way this live stacking works. You can see we've actually captured 20 now images of this object in a very short order, just 3 minutes and 20 seconds. And you can already see all that detail of the filaments of this galaxy, just like the guy was saying in the narration. I hope you were able to hear that. We're now at 100% of the camera's view, and I use a, for better for worse, I use an approach with this camera right now called 2x2 binning. And our astronomers that are listening in that are experienced will know that what that means is you're basically batching your little sensors inside of your CMOS camera together so that you can use four of those light buckets together in one and consider that one dot. That does decrease the resolution a little bit, but you can see it does bring in the slightest hints. And boy, just look at that, how we're starting to see. The problem is you can't enlarge it much without getting some pixelation. But boy, even right there, that's just really letting us see a beautiful view of this very small dot. Remember what the guy said, if you don't have a telescope, this just looks like a dot. Now I'm going to take a risk here and try to do the color balance again, I think. Just because now we have more. Oh my goodness, it's such a mess, isn't it? We have a little more, a few more subframes to choose from. I don't think it's going to do very well on the auto color balance. So I'm gonna take a, uh, just try to manually. Sometimes just the slightest change makes the biggest difference. Look at that. Look how cutting down that green, color matching. You know what? Let's reset this first. Over here, this is the display histogram. And sometimes when you reset that, nope, that's not going to help much. Uh, I tell you what, it's really favoring the green. I'm going to just give it a little more red. Now we're talking. Just a little more red to kind of balance out that green. And then also, you could try to take it. No, it's not liking that. Oh my goodness, look at those spiral arms out there. Now I don't want to get it so big that we pick up. Oh my goodness, look at it. Throw out that star material. Now we're blowing out the middle some right now, but it's almost worth it, isn't it, to be able to see all that star material to the side. Well, this is what you can do in EAA, electronically assisted astronomy. If you do have a fairly good optical tube assembly, and the RASA, in my opinion, is a good light gathering scope. In terms of focal ratios, if you're into that sort of thing, it gathers light. It is extremely sensitive to light. So astronomers refer to it as being a very fast telescope. Focal ratio is right around 2. And a lot of telescopes, the one I had before, it had a focal ratio of 10. Now that might sound like that this RASA is 5 times more sensitive, but those scales are actually, what do you call them, logarithmic or something like that. So actually, there's more sensitivity than you might imagine. Uh, the difference between a focal ratio of 2 and a focal ratio of 10, and I don't have this memorized, but it might be 50 times more sensitive. And boy, we're seeing it on this object, aren't we? We are picking up all those beautiful, look at it throwing off all this star material out here. Wow, those spiral arms. Look at that. Uh, and this is a difficult object. This is a visual magnitude of somewhere in the between 8 to 9, and I have a little bit of moon left out. Not much, to be fair. No, the moon's almost set now. But the surface brightness on this is not that high. Uh, when you take this out across its I don't know, 11 or so arc minutes of surface, and you average out all that, say 8.5 or 9 visual magnitude, this is a difficult object. And Probably, if you just go out in a like a 6 inch or a smaller scope, this is going to be a tough object to pull in. But again, this camera is what's doing the trick. It's not just the telescope; it's that the camera is so sensitive to light, and we've overlaid 50 frames, about 8 minutes, probably long enough on this object to be able to enjoy it. So what we'll do, let's just check the. Do I dare try to do another? Oh, that it really wants to have green, doesn't it? I'm gonna just bump up the red a little bit more because I think that's more realistic with this object. Wow. You know, colors notwithstanding, since I'm a little bit color deficient anyway, the truth matter is you can now see those spiral arms and some of that dark dust lanes between them. That star right in the middle. Isn't that beautiful? That dot right in the middle like that. That that star or that hub, whatever you want to call it, is is very large, and it's of course surrounded by these spiral arms. It's got that patchy spiral uh, pattern in it. Uh, Boy, I just appreciate you joining me tonight while we've looked at the sunflower galaxy, as they call it, M63. I'm going to go ahead and save a picture of this so that way we can remember what this looks like. And I'm going to go ahead and say goodnight. This is probably a chance for you to see what I'm doing out here tonight. It's probably, what is it, 3:19 a.m. And I'm having a blast. I started around 6:30 or so with the setup and got going around, boy, it was probably 8:15 p.m. before I could get everything working exactly the way I wanted it. Uh, and I'm still having fun. So uh, really nice to meet you. Don't forget to go to emeraldhillskies.com, and there's a place there you can put your email address in, and that way you'll be alerted to about nights like tonight when the sky has been clear. We usually give you a couple of days advance notice, and that way you can join us again. I hope you will, and it's been great talking to you. I hope you have a good rest of your evening and good night. Take care. God bless.